Before we get started with the Q&A, I just want to give you a little bit of a background of the way that I'd like to do Q&A. By the way, I just want to say I just commend you for sticking out for all of the talks and stuff, because it shows to me two things. It shows me your grace in this process, but also it is an encouragement that you want to learn and to be able to answer some of these questions. One of the things within Creation Ministries International is that we are trained as speakers to have a wide band of knowledge on most things, but not everything, because no one can be an expert in everything. And my background is in sciences and stuff, so I can answer those. If there is a question that I can't answer, I'm going to defer to the pastor, because he said that he would be more than willing to answer those questions. That's not what he said, but I'm just going to put him on the spot there. What we're going to do for this is we're going to put a time limit at 45 minutes, okay? And we'll try to adhere to that. I really am so blessed by the number of young people that are here, and also your folks is willing to pay attention to and just to bring this stuff in. It is really a blessing. I think we live in a world today that so desperately needs to hear these fundamental truths. It's not just about creation, but a whole bunch of different things. And the reason being, as the pastor alluded to earlier, our world is in a downward spiral of what they are capitulating to and what is being allowed to be taught. And so I believe that not only is the church the core of society, but the church is also going to be the core of what the future is as well. And I see all these young people here, and that's a great encouragement. I have said to another gentleman I was visiting out with earlier, I've been to many churches when the last person passes away, we shut the lights off. And I believe that the health within a church is multi-generational. We need all of them. We need the old seniors like me, we need the middle, we need the young people. And there has to be that interaction between those generations. And I think that is a sign of a super healthy church. I've shared this verse already, but I will just give it to you once more, that we sanctify Christ as Lord in our hearts, being ready to make a defense to everyone who asks you to give an account for the hope that is in you, and yet we do with gentleness and reverence. When I refer to the gentleness and reverence, we do this because if you want to get into an argument with somebody, there may be an opportunity to pound them in the ground, but it doesn't do us any good if that person walks away. And so may it never be that for myself or any conversation that you have, that you would be the cause that somebody decides to walk away. We need to work together through these processes, and there's always questions that are being asked, and there is always answers for them, because God's word is truth, and we can trust in that. Over the years, I have had what I called my top 20 questions. And over the years of doing this a couple of hundred times, I sort of whittled it down to my top 10 questions, because the other ones, there was either repetition or whatever. And so what I'd like to do is this. If you would like me to answer one of the top 10, I'm going to take 2 minutes to go through all of them, just so you know what the question is asking. Or if you have another question that's not on here, I will try to answer the question, but I don't necessarily will have the answer for those things. My only request is this, and I want to be gracious. Please make your question in one sentence, and there has to be a question mark at the end of your sentence. Because I have gone into places, and the person wanted to go on for 17 minutes about everything that they knew, but that's not question and answer. That's just someone sharing with what they thought that everybody else should know. And so I just graciously would like to ask, if you do have a question, it just has to end in a question mark with one sentence, okay? So, in no particular order, here are the top 10 questions that I get asked, and we can ask these ones, or we can go to ones that are on there. Addressing the flat earth question. I have spoken in many places, and there's many folks who believe that the earth is flat, and so I will go over that, and I will try to be gracious to you as I give that answer. How does carbon dating work? Because it's the method that we use scientifically to possibly give the age of something. Who was Cain's wife? That is a sort of a biological question, and I think that we can probably work that one out fairly quickly. Were dinosaurs on the ark, and was it big enough? I'd say yes, because I just did the dinosaur talk. How can we see those distant stars if the earth is young? There are 5 different answers for this today. I don't know if any one of them is better than the other. I choose just one of the 5 because otherwise it takes about 3 hours to go through all 5. So I choose one of those to talk about that. Was the flood global or just local? It was a global flood because it was the punishment of sin. If it was just a local flood, then these guys got wiped out and these guys got away with it. So that's not going to work. There is evidences around the world, and I will just show you some stuff that is kind of local within North America that I believe is going to be evidence for a global flood. Where did all the races come from? That's a biology question. I will just show you just very gently and graciously on how biology can show genetic variation. About the Ice Age, where does that fit? As creationists, we absolutely believe that there was an Ice Age, but there was only one of them, and it wasn't for millions of years, and it wasn't that long ago. And we can show you some of the different really good evidences on how this can be handled. I think we're going to skip number 9 because that's a fairly long answer. How do you compare the various origin theories? And can you be a Christian and still believe in these theories? And so I will say, yes, you can still be a Christian because the message of salvation is not based on whether or not you agree necessarily with the creation, although I think that there's been enough proof that you really don't have the gospel message unless that is such. But anyways, that is a very long answer, that question. It's about 30 minutes, so maybe we'll just leave question 9 off the chart today. And did life on Earth come from Mars? This is a very popular question today because they say that life did not originate on Earth. It came from somewhere else. But then the question is, well, where did that life come from? Well, it came from, eventually you got a dog chasing its tail. You have to tell me where it started from. We have problems with on distances and time and so forth. Life did not come from anywhere else. However, there are certain people today that are using that question to reach into the hearts and lives of our young people, and what they're really doing is they're planting a seed of doubt, because once you plant that seed of doubt, then you can mess people up. All right. I will also allow for any other question. If you can just yell at me, that would be wonderful. Oh, we got a microphone. That's great. So just raise your hand and you can say, can you do numbers? Or you can, there we go.
Yes, close. So you suggested that there's a very limited, if at all existent, fossil record of humans because they were too smart or too fast to escape the flood. Sorry, that's not a question. Here comes the question. If that was the case, then did that undermine God's plan to annihilate humans through the flood? And off the back of that question, does that mean we're not necessarily Noah's descendants?
Well, everybody died because you can only swim for so long. And if you are swimming, then you become a tasty supper for other creatures that like to eat you. So we're going to put our trust in God's word that it says that everybody's going to be a descendant of that. That's where the pinch point I call that we're descendants of one of those 3 different people groups. And even though there's not a lot of fossils, that doesn't mean there wasn't a lot of people. And so their remains were not fossilized, but I don't think that they survived the Jaws attack of certain bigger creatures. And I still believe that there's no contradiction in God's word that we still are all the descendants of those. We are descendants originally from Adam, because in Adam is a typology of Christ, and then we have the descendants that come from Noah's flood. And from that, from the 3 brothers, you get the 3 different people groups. You'll get the black folks, you'll get Asian folks, and then you'll get those who are more white Caucasian. And the rest of those, all the other people groups, they all fit genetically into one of those 3, which is interesting. I think God had that all figured out. Thank you for that question. That's excellent. Any other ones? Any numbers?
I would like to know a bit more on Number two, how reliable is carbon dating? Because I hear that often.
Sure.
That's how they know.
Excellent. Carbon dating. Here we go. That's bad pun. That's terrible. You said it's not for singles because it's dating. Never mind. This is a commonly asked question. So what I'm going to do is I'm going to sort of invite you into what I would consider my grade 10 class, and I would teach this in the physics unit. And let's just do this together here. So what we're really looking at is called the radiocarbon decay process. That's its technical name. And let me ask you a question. The goal of every atom is to be what? If you are an atom, what is your goal in your life to be? Well, of course, it is to be happy. So we have happy atoms, which would also mean that we would have, what would the opposite of a happy atom be? An unhappy atom. So we can then decide that happy atoms and unhappy atoms will be our foundation on how we figure out this process. The radiocarbon decay process in its very basic form is just simply this. There is an element called carbon-14, and 14 is the number of its weight, if you wish. I can go into really high technology with this, but you don't need to know that. So carbon is an element, and its weight is 14. Now, carbon normally has a weight of 12. So that means that it is heavy. It is supposed to be 12, but it's actually 14. And we give a name to that thing. It is called the parent element. And kids love this because they find out that their parents are unstable. So what happens is the goal of every atom is to be happy. So if you are unhappy, then that must mean you must be unstable. And so the goal then would be to somehow go from being unhappy 14 back to happy 12, and life is wonderful. The way that you go from 14 to 12 is through this process called decay. And decay is a very complicated process. I'm not going to go into it, but the end result is nitrogen 14. Now, you'll notice that the color not only has changed, but the mass has stayed the same. So carbon is happy at 12, but nitrogen is happy at 14. So if the element nitrogen is now happy, we call it the daughter element, and it is now stable. So now I'd like you to make the connection between unhappy means unstable, happy means stable. So far, so good? That process is called radioactive decay, and it's measured by something called the half-life. Every single unhappy element has a process where it can decay and become happy. And for carbon-14 to go through this process to become nitrogen-14 is measured as half-life, and it's fairly agreed that it is 5,735 years. And that's a fairly easy thing to measure because there is instruments that we can measure that. Let's take a step back and let's figure out, how did things become unhappy, unstable in the first place? How is carbon-14 produced? There are 5 different methods. 4 of them are very technical, very complicated, and fairly rare. So we'll just focus on the one method that happens most often. We have cosmic radiation that comes from the sun. The sun is constantly giving us radiation, and we know that. And what happens is it collides in the atmosphere with a nitrogen-14. So nitrogen-14, is it happy or unhappy? It's happy. It gets bonked in the head and gets clinked with something, and it goes from nitrogen-14 to carbon-14. So this is on how it started out. It started out as happy, and now it's rats. I'm now unhappy, and it wants to go back to being happy again. Everyone following so far? Okay. Carbon-14 then combines with oxygen to form carbon dioxide, which we know our atmosphere is filled with carbon dioxide. Now, carbon dioxide is a wonderful gas because plants, they take in carbon dioxide. Carbon dioxide is what they breathe in, and they breathe out oxygen. So as much as we love oxygen, plants love carbon dioxide. Now, what happens is one of two things. Either the cow eats the plant and we eat the cow, or we just eat the plant, but in either case, every living thing that eats plants then has what now inside your body? Unhappy, heavy carbon-14. So if you wake up one day and you go, man, I'm feeling really heavy, maybe you just took in way too much carbon-14 the day before. When you are doing that, there's something that happens with inside your body. Carbon-14 then exists in your body and it builds up to a certain position. Now, something really important happens when a tree or organism dies. So when we die or when the tree dies, it no longer can take in that unhappy, heavy carbon-14. And this is where we say the decay process starts. And this is where I say now the clock starts to tick. And the clock ticking then is we can measure then how old something is based on that unhappy-happy ratio. If you were to graph this, what you end up is a graph that looks like this. This point here is the point of death, which means you're not taking in anything more. And then that stuff starts to dissipate. That's the decay process. So far, so good? And that time period can be measured fairly accurately at 5,730 or 35 years. So what happens is that each one of these things is half of what it was before, and that's where the name comes, half-life. And so it goes on and on and on, and by the time this graph reaches about there, guess what happens? What happens to the amount of carbon-14? It doesn't exist anymore because it has gone from half to half to half. Eventually there's no more. So here's the most important point. There is no more carbon-14 after 90,000 years. All those unhappy nitrogen-14s have now turned back into happy carbon-14s, and we say then what happens to the clock here? It stops. Here's the most important point. Only living and once living things can be measured using carbon-14. So if they say something is 5 million years old, did they use carbon-14? No, because carbon-14 can only measure to 90,000 years. There is no other method to measure once living things other than carbon-14. So when they say that such and such is 10 million years old, what they're doing is they have to put it into their chart of where they think it came along on the evolutionary timeline. At that point, it's not science anymore, it's speculation. Okay? So 90,000 years, there is no measurable carbon-14 anymore, and anybody who says that they've measured it is lying, because there's no way that you can measure a living or once living thing past 90,000 years. Now, here's the problem. I showed you this chart in my earlier talk, and what happens is we have all these fancy names here, and they've assigned these numbers. And Ma, stands for mega annum. Mega for million, anna for years. Mega annum. So what they said is that this period is 37 to 56 mega annum. Is that using carbon-14 dating? No, because it's way past what? 90,000. So here we have these guys here at 318 Ma. It has nothing to do with time. It has to do where they think this fits into the evolutionary timeline. So is this scientific? No, because it's not measurable at all. I said that this whole chart is just simply on how smart you are and how fast you can run. And that's it. And by the way, there is nothing laid down in the geological time frame in the rock in that order. It's all mumbo and jumboed. But they don't want you to know that, because then that would take away their presuppositional worldview that it has to be zillions of years old. Something very interesting happened in Oz in 1994. They were digging way down there, and they found this clay layer way down here, this basalt. And what they found was tree stumps, 69 feet under. Now, I wonder how those tree stumps got way buried underneath there. Please say global flood. Okay? Now, here's the problem. The basalt layer, which is the the minerals and the rock and whatever, they measure this at 45 million years old. So they obviously did not use carbon-14, did they? They had to use a different method. What's interesting is they say the wood's between 44 and 45,000. So which one is right and which one is wrong? Well, the problem is that they pick the age according to what it fits into their chart. Let's have a look at some of these things. Let's have a look at coal. They say if we radiocarbon date coal, it's 52,000 years old. Is that within the range of what is allowed? Yes, it is, because it's between 0 and 90,000. Okay, we don't know what the starting amount was, but that's okay. The geological age is 37 up to 318 million. Folks, is this good science? No, this is a range which is unacceptable. It's sort of like saying you owe between $52,000 and $318 million to the government. Well, what is it? Or the government is somewhere between $52,000 and $318 million in debt. It's not very scientific. So which one is right? Well, there's a problem because as soon as you have presuppositional worldview, you base things on what you think it should be, not what you can actually measure. Here's some of the problems with carbon dating. If carbon dating started, the process to make an unhappy carbon-14 started at the beginning of creation, what would the carbon-14 level be at creation then? 0, because there wasn't any. Then the sun rays started to come and away you go. Then at the flood, it's been around for a bit, guess what happens? Well, you've got a little bit of carbon-14, and today we have a whole lot. But you see, the problem is that we have no idea what this number is here. Why don't we know? Well, they've only invented these machines within the last 100 years. So we have no idea what these numbers are, and so what you do is you call that bad math. If you have no instrument to measure on how much something is, then how do you say that? There's something that I really, really go nuts over. It is the hottest day in the last 300 years. Well, I'd say, well, when was the thermometer created? 1867. So how can it be the hottest day in 300 years when the thermometer was only created 150 years ago? Do you think anybody 500 years ago went out and measured the temperature of anything? Not a chance. They didn't care less about what the temperature was. And so when we say these things, you need to have that discernment level to say, well, wait a minute. We never even invented machines to measure this 1,000 years ago. How do we know what it is? How do we know what the temperature is not in 100-year cycles, 500-year cycles? We only invented the thermometer in 1857. The first thermometers were things that went up when it got hot and went down when it got cold. Well, how scientific is that? How much measurable is that? It's nonsense. All right. When we have the flood, the levels start up. When we have today, we have this. Here's the problem. Plants discriminate against carbon dioxide containing carbon-14, and different plants discriminate differently. I don't know if a plant goes, oh, carbon-14, I don't want that. I don't know how a plant is smart enough to do that. The less, here it is, the less carbon-14 taken in by the plant will also give a false older date. And so that's the problem. And scientific measurements must assume a closed system, which means nothing can get in and nothing can get out. When I taught chemistry at high school for many years, I said all the chemistry that we do is sort of like in a pickle jar. It's sealed. Nothing gets in and nothing can get out. Is the world we live in a giant pickle jar? It's not. It's an open system, which means anything can get in and anything can get out. And how scientific is that? 0. You can only do science in a closed system. So that is an impossible thing. This closed system is impossible to figure out. Here's another one which is really critical for us today. The amount of cosmic rays that penetrate the Earth's atmosphere affect the amount of carbon-14 produced. The Earth's magnetic field is decreasing, so more carbon-14 is being produced today. Let me show you how this works. Here we are on the Earth, and we have a magnetic force field, and that's used to use a compass, right? And that magnetic force field acts as a protection around the Earth, so when the radiation comes from the sun here, it hits this protection, and it gets bounced away. As this magnetic force field starts to decrease, the amount of radiation that hits the Earth starts to increase. And that, of course, is going to give us a false date. Now, I was born in the 1960s, and when I was a little kid, my mom, at 5 years old, in the summertime, kicked me outside and say, I'll see you for lunch or supper. And the first thing I did as a little kid was take my shirt off, and I would run around, and by the time September came around, I had really dark skin. Now let me ask you, if you took a little child today that's 4 years old and you kicked them outside in today's radiation, what's going to happen to them? They're going to burn crispy in about 2 days, and then you're going to get a knock on the door from social service and say, your child is burnt to death here. I'm going to take that child away. That shows in just my generation the amount of radiation increase that has happened just in my 60 years of life. That's incredible, because at this rate, what's going to happen in about a couple hundred years from now? The amount of radiation that actually reaches to the Earth's surface, we're all going to walk around in these tinfoil suits, because otherwise we're going to fry as soon as we walk outside. Is this good science? Well, it's good science to measure this, but it's not a good science to measure what things happened in the past. The effects of the global flood would also completely alter amount of 14 and 12 ratios. Why? Volcanoes emit huge amounts of carbon dioxide, that's called volcanism, depleted of carbon-14 because the carbon dioxide in volcanism comes from within the Earth, and that means it's not exposed to the radiation, so therefore we're going to end up with false dates. And of course, the flood was accompanied by a lot of this volcanic activity. What then is radiometric dating? Well, it's the same principle, except we don't use carbon-14. The main difference is it now measures millions and billions of years, and it uses elements outside of carbon. So then we have strontium, rubidium, and all the rest of these things, which can measure apparently millions and billions of years, but I'll show you why that's wrong. Let's pretend for a moment that we have atoms that are gray, and they're going to go through this decay process, and eventually they're all going to turn into the daughter elements, which are red, okay? So here's the problem. In the process of going from gray down to red, we assume that we know what these amounts are. When I was a teacher, I used to do something very mean to my grade 9 students. I would say, class, if a tap drips 2 milliliters per minute, how long will it take to reach its current volume of 36 milliliters? And every child takes out their calculator and goes 36 divided by 2 equals, Mr. Janzen, 18 minutes. And I said, I'm sorry, you're wrong. It's only 8 minutes. And they would go, what? That doesn't make any sense. I said, I know, because I didn't tell you that the starting volume was 20 milliliters. Well, that's not fair. You didn't tell us. That's true. Here's the problem. What is the starting amount of any of these things if they're very old? We have no idea, because these methods always assume a theoretical start of 100%. But these machines have only been around for 100 years, so we have no idea what their starting amount was 100 years ago, 500 years ago, 1,000 years ago. So what would happen then is that the actual amount was only 12 and a half, and then today we have only 12. How much has actually gone? Only 0.5 of 1%. Except when we measure this, we're going to assume that it started there, but it actually started here. What's that going to give us? An incredibly false date, because we have no idea what the starting amount was. We don't, because we haven't been around long enough to measure these things. Here's the problem in assumptions. The starting conditions are unknown. We have no idea what these things were. Only those things with short half-lives can we measure. There's a whole bunch of things that have a half-life of a half a second or 5 seconds or whatever. What's the half-life of carbon? 5,735 years. In other words, we have no idea on how much parent isotope was actually present. What was its starting amount? Decay rates have always been constant. We have no idea if there's been a consistent thing, so it's this well, I'll do it this way, a beautiful curve like this. We have no idea, because all we're measuring is data on the curve itself. Closed system. Do we live in a giant pickle jar? No, we don't. We don't live in a giant pickle jar. So that means that things can do what? Get in, and they can also get out. There's no other outside influences like radiation or magnetism. We haven't been measuring the magnetic force field of the Earth for very long, and so therefore, how much are we being protected? We know that the Earth's magnetic force field is decreasing. So that is bad news, but we have no idea on what it was earlier. Here's the conclusion. Radiometric dating methods are driven by, a worldview that cannot be proven and follows uniformitarian mechanisms. We talked about that in the first talk this afternoon. They are also driven by long-age assumptions that pervade academia today. Why do people want to believe in evolution? Just for curiosity's sake. What is the foundational thing for people to want to believe in evolution? This is critical. There's no need for God. Because if evolution is true, then no God is required. If no God is required, then therefore I am not accountable to anybody, so therefore I can do whatever I please. That gives man a license to sin. And you see what drives this. It's all about me. It's all about what I think. That is the problem in academics today. Scientists can only measure isotope concentration ratios that are very accurate, but the assigned age is based on unqualifiable assumptions because we have no idea when these things started, and if we have no idea if these things are consistent, especially over long periods of time. All of this is to say this stuff is really bad science. And they're going to pass it off to you, and unless you have a little bit of an understanding of this, you're probably going to buy into it. And I've been debunking this for about 30 years now, saying this is not good science. But you see, they've made science this God that science tells us everything, and science is going to show us. And I would equivocally say that this stuff is very bad science because it actually doesn't follow the rules that you have to do. I don't know if we have in the back there, Elaine's packed it away. Radioactive dating in a young Earth is done by my friend Dr. Jim Mason. He does a very interesting thing there. He sort of goes through all the different processes and you get an idea. He does have his PhD in nuclear science, and so it's a little bit higher level. There's also a brand new product that we have from CMI. I only saw it about 2 weeks ago, and you can order it online. It's done by Spike Saris, who used to be a NASA engineer, and he gives a very nice, clear presentation of the 5 different things that we can use now for radiometric dating and old Earth and all the rest of those things. So you can order those things online. There's a little pamphlet there, and that's kind of a cool thing. But it's 25 cents worth, and it's just an introduction to get people curious about those things. I don't know if that helped you, but I just want you to take away that radiometric dating is based on a bunch of assumptions that can't be measured. It is not scientifically qualifiable. We have no idea what the starting amounts were, and it's really bad science. And they use it because they want to have their worldview put together. Yes, sir. Oh, you're the microphone. I thought you were going to come up here and take over for me. I'm good with that. Another question?
Got a keener here.
You only get 2.
Good thing I can't count. So you talked about red blood cells found in that dinosaur bone, that femur that was cut in half. You also said about them decaying in a week on a shelf, but the red blood cells were very much not decayed. So do we have any idea how old those fossils would be from the state of those, or does that fit in with your carbon dating there, that there's too many variables?
Well, there's a lot of variables in there, and I love that because Dr. Schweitzer said, when you put a blood sample on the shelf, it's turned into guck in a short period of time. The interesting thing about Montana is it's sort of like Alberta in the sense it's warm in the summer and cold in the winter, and that fluctuation of hot and cold is a really lousy thing for preserving. Take a roast and stick it out in the snow out here, and it'll be okay for a bit, but if you leave it out there for several years, what happens in the summertime here? It warms up and your pot roast is going to be no good anymore. And so all of these methods really show a couple of things, is that red blood cells do not last for millions and bazillions of years. And I just think it's by God's grace that some of these things actually, they had to be encapsulated in a way that they were sealed off from oxygen. Oxygen is one of the great catalysts for a lot of chemical reactions, but it also kills a lot of things too. Oxygenation is a wonderful thing for us to breathe, but if you want to actually decay something really quickly, then you give it oxygen and it's going to degrade. So the fact that they've even found red blood cells in dinosaurs would indicate that it is impossible, even if you stored this dinosaur flesh in, liquid nitrogen at a zillion below, it's still going to be degraded. It's not going to last for, 65 or 85 million years, especially soft tissue. There's actually a little video on CMI that shows Dr. Schweitzer with 2 sets of tweezers underneath the microscope and going this with the elastic nature of these tendons and stuff. That elasticity is not going to last for millions and millions of years. These creatures did not die out from that whatsoever. The degradation of tissues and blood and all the rest of these things are just proof that these systems are based on a false narrative that they've conjured up in their mind. And what's very interesting to me is that Dr. Schweitzer just grits her teeth and she says, I do not believe that the earth is young. I just can't believe it. So if you don't believe something, what do you do? What do you do if you don't believe something? You just say, well, I don't believe it, but I don't know what else to say. Because if you say, I do believe it, then that puts you in what kind of a position? A position of accountability. There's lots of people that say, I don't believe in the Christian faith. Well, as long as you say, I don't believe in the Christian faith, then that makes you, I'm not accountable, but that's not true. Just because you don't believe in something doesn't necessarily mean that it's not true or there's not going to be consequences for it. That's the scary thing about accountability. The accountability is always there. It's what you want to do with it that is the important thing, and that's the decision that you get to make. Will you bend the knee or not? It's the same message of salvation. Good questions. Any of those other questions? Or a question that you have that you can put a question mark at the end?
Could you talk about number 5?
Number 5, distant stars. Love it. This one's a little bit on the physics side. I'm going to give you a version I think that we can probably handle. How can we see distant stars if the Earth is young? Well, let's first establish what is not true, because a lot of people want to talk about things and I'm just saying, well, that's not true. Okay? The first one that's always given to me is with the speed of light changes. The speed of light only changes as it goes through different mediums. So, for example, the speed of light through water is going to be at a different speed than it goes through air. C is a constant. C is the symbol that we use in physics for the speed of light. Okay? So whenever you see a physics equation with the letter C, they're talking about the speed of light. Einstein, E equals mc squared. That means the speed of light squared. That God made light in transit. This is a possibility that God made light in transit, but there is enough physics that we can say we don't need to use that. And it is a little bit deceptive that God was deceiving us by going, ooh, it looks like it's millions and billions of years old, but I'm going to stretch the light out and I'm going to say it doesn't look like that. And all of a sudden then it loses its measure of credibility. And so we just say, well, look, we don't have to believe that God made light in transit. We're just going to assume that the speed of light is a constant thing. That the Big Bang Theory is universally accepted. There are many scientists out there that do not believe in the Big Bang. And so they say, well, if you don't believe in the Big Bang, then maybe you should believe in creation. And they say, no, we're just waiting for something better to come along. Well, you might wait for a very long time because the Big Bang is not universally accepted. There are many problems with it. The two most common ones are the horizon problem, which is uneven temperatures, and the second one is the space inflation problem and how fast the universe is expanding. That's why I love things like Hubble telescope and now the James Webb telescope, because they're just making a mess of physics right now. They're showing that things are way bigger than what we thought they were, and there's a whole bunch of things out there that we never thought could exist. Let's have a look at some of the possible theories. We're going to spend a few minutes looking at Einstein's theory of relativity. I understand my audience. This is not second-year university physics. I'm going to just talk at a level that I trust we'll be able to figure out. If you were in grade 9 in BC, you have to know this formula. Speed is equal to distance divided by time. So V stands for velocity, which is speed divided by dt. Okay, let's pretend that The distance between here and Edmonton is 200 kilometers, and it takes me 2 hours to get there. So what is my speed? I'm doing 100 kilometers an hour. Does that make sense? Okay, so that's that. So the distance is probably fairly accurate. We can measure these distances out there. Speed is not changed because I'm going to trust that my speedometer on my car is accurately calibrated, and so I can measure. And then we take these things and we put them out in space. The problem is time. Time is not an absolute, and this is according to Einstein's theory. Every first-year university physics student used to have to do this experiment. They don't do it anymore because it messed up way too many people, because they showed and they proved that this is the problem. So let me show you what happens here. Time can actually change. You may have never heard of this before, but clocks actually run at different rates depending on their environment. So a clock, according to Einstein, ticks slower when it's moving faster. That's called special relativity. So if you have a object that has a clock on it and is going super fast, the time is actually ticking slower. They've proven that many times. General relativity says that clocks will tick quicker when they're in lower gravity. So where would the lowest gravity be? Well, there's a bunch of different places that we can have lower gravity, which would be at sea level. As we go up, then it's going to tick faster, and then speed also comes into it. What we believe and what we teach at CMI is what's known as the space-time velocity time dilation theory. That's a lot of words, but I'll show you very quickly how this works. Way back when, we have this dude, which is Isaac Newton, and he came up with the X, Y, Z axis. This is on how you can play certain games. You have an X-axis, a Y-axis, and a Z-axis, okay? Those 3 dimensions. Very good. Albert Einstein comes along and he says, yes, we have X-axis, Y-axis, and because time can change, we're going to add time to the mixture, okay? X, Y, Z, and time. And then the reason why we add time is because those clock rates can vary, so it's not a constant. This is Dr. Moshe Carmeli. He was an Israeli cosmologist. He was not a believer, and he has since passed away, and he developed some equations, and he said this is what's called cosmological special relativity. He takes Newton and Einstein and then adds another dimension. This is called the 5th dimension, and he calls it the space-time velocity equations. Now, Dr. John Harnett, who worked for CMI in Australia, he sat down one day and he solved Carmeli's equations, incorporating the stretching out of the heavens like a garment, mentioned 16 times in the Bible. And so Carmeli, he gave the equations. He wasn't a believer. Dr. John Harnett added the equations together and put this all together, and he said that God stretched out the heavens, and in this process, come up with what's called the clock rate variation with acceleration equation, and we go from there. This is the equation. I'm going to break this down for you very simply so you can see the math. Little d, little t is the Earth-based time interval. So us on Earth, we are going to be measuring little d, little t. So far, so good? Okay? Then what we're going to do is we're going to go little d, big T of what's going on in space, because space has got something weird going on out there, so we're going to use a different equation for them. And this is the equation using the Carmelian equation. We're not going to figure this out. But here's the deal. When we have a fraction, as this number here gets bigger and this number stays a constant, then what happens? So let's have a look at the acceleration of the fabric of space brought into this equation. If acceleration is very large, then the Earth-based time interval is shorter, this is Earth here, than the galaxy-based time interval, because as this number gets bigger, then this number gets smaller. Let me show you how that works. Let's compare 2 fractions. 1 over 2. 1 divided by 2 is 0.5. But if I make the bottom number a little bit bigger and change it from a 2 to an 8, look what happens to the number. It becomes progressively smaller. So the bigger we make this number, which means the bigger that the universe is, then what happens to the actual time here on earth, it gets progressively smaller because the denominator makes the answer smaller. I asked my friend Dr. Jim Mason, I said, Jim, this is going to be too hard for people to figure out. Can we come up with a diagram? He said, yes. So he said, look, this is the entire universe. And the earth is at the center of the universe, and around it we have the sun and the moon. This is not to scale, okay? And then what happens is that the universe expands because everything's moving away from everything. So everything is expanding. What he says is this. Our point of reference is the earth here, and so from where we are to where we are when the universe is expanding, there's no acceleration because our position has not changed. We're still here. Does that make sense? All right. What happens then when we have this thing, whether this is a star or this is a galaxy, and it has low acceleration, it's moved farther distance away, what happens to the clock? The clock starts to tick faster because of Einstein's equation. What happens if there is a high acceleration and things move very far away from Earth? Why the clock then ticks very fast. And remember that as the denominator gets bigger, then what happens to the number? It's going to get smaller. There's a whole bunch of other physics in there. We're not going to look at those things. Here's the conclusion. Scientific discoveries continue to support the authoritative Word of God, but it takes time. Think about medieval textbooks that have changed since the 1800s. Back in the 1800s, if you had a headache, what did they do to you? They drilled a hole in your head because you got too much pressure, and they did bloodletting. If you go to the doctor today and say, Doctor, I got a headache, they said, just wait, I'll go get the Hilti drill and we'll just put a little drill in that thing there. We'll take care. We don't do that, do they? And so as medicine changes, science changes, and physics changes, but we're just getting more and more accurate is what happens. Only God possesses infinite knowledge, not man. With human limitations, the time dilation theory may still require review and refining. Since this time that we have come out with this thing has been refined a few times, and we're getting closer and closer to numbers between the 5,000 to about 7,500 years, maybe 8,000 years. So the refining process is not making this thing millions and billions of years. As we discover on how big the universe is, that makes the clocks change, which means that the time here on Earth is going to be a thing that we can measure. I don't know if that helps you. There's the distant starlight dilemma, which is by Dr. Jim Mason. You can order these online, and also the one that has come from Spike Saris, and he goes through the 4 or 5 different methods that we can use to measure this. The encouraging thing is that this research is done by scientists who are, first of all, by the most part, like Carmelli was not a Christian man, so he didn't have a bias. And the second thing is that they're getting better and better at this. Anybody who wants to make the world billions and zillions of years old, what they're really trying to do is allow for a time frame for evolution to possibly happen. And we said if the longer the time frame, then they say, well, therefore no God is required. Do we have to lose our mind over this? No, thank you. Because does God's word change? No. Is the message of the gospel clear in here? Yes, you shared the message of the gospel. So when we do these things, this is what I would call second, third order, fourth order questions. Will we continue to study this stuff? Absolutely. Are we ever going to figure it out? I think in my own heart, God's going to say, you know what? I just kept it from you all the time because I just wanted you to just keep on relying on me. Because as soon as you rely on man, then you're going to take your eyes off of him. I don't know what the answer to this. No one's going to be able to tell us this. We have physics that can show that the world is not millions and billions of years old. It's still a matter of faith. How we handle that is a matter of the heart. Does it affect the message of the gospel? It does not. It's a good thing to know, though, and say, well, there are answers for these questions. I think we got room for one more, and then I think that's going to be our 45-minute time limit. We're at 30 minutes now already. We'll do one more question. Or 2 if they're short. Any of these? This gentleman over here has one.
Could you talk about number 8?
Ice Age. Love this question. This will bring us perfect. It's the right amount of time to cover this one here. What about the Ice Age? Well, evidences for an Ice Age include glaciers and U-shaped valleys that they carved. Okay, so that's how we see whether there's an Ice Age. So there's two different types of geological features. We have these U-shaped valleys and we have the V-shaped valleys, and I'll show you on how they differ. Evolutionists believe there's been multiple ice ages occurring every 20 to 30 million years, and they've lasted up for millions of years. Creationists, however, believe that the Ice Age was triggered shortly after the flood. I'll show you how that works, and lasted for less than 1,000 years. I'll show you how that works. The first thing that we need to understand is the mechanisms to start an Ice Age. To start an Ice Age, you need basically two things. You need to have a warm ocean. And the reason why you have a warm ocean is that there's more evaporation, which forms in the clouds, and it comes down as snow if the landmass is cold. It comes down as rain if the landmass is warm. So, in the process of a global ice age, we have to understand two things. First of all, not everything was covered with ice, and the second thing is that there are certain things that have to happen in order for this to work. One of them is this volcanic ash blocking out the sun. Because in the global flood, there was much volcanism, and that would also cause the sun to be blocked out, which means that there's going to be a warming greenhouse effect, which means that there is going to be evaporation, and then the landmass is going to get cold, and this is what we like if we are skiers. You want more of that stuff. The extent of the ice sheet is given here in red, and it clearly shows that not the entire landmass of the Earth was covered in ice. In fact, it looks like those of us in North America and up here, Greenland, are worst off. There's a little bit down here in South America. This corresponds with a very high mountain range. Isn't that amazing? There's other parts along here. No one lives up here, so we don't care. And these ones over here, this is probably like where the Himalayas are and stuff. A little bit of this area up here, pretty cold up there. Yeah, that's not very good. Oh, these guys down here. So we see that the Ice Age was not a catastrophic global event because that probably would have wiped out everything. There's lots of landmass where everything else can exist. Let me share with you this little story from World War II. We have these P-38 aircraft, and apparently this thing kind of crash landed in Greenland, and the plane was abandoned. This happened in 1942 because they ditched the plane, and they said, we're out of fuel or this thing doesn't work. We're out of here. So they ditched it. So they know on how old the plane was when it went down. The plane then was recovered by a bunch of people that said, you know what, if we find these old planes and we reconstruct them, we can make some money. So in 1992, the plane was recovered. Now the math is good here because we can do this. 92 to 42, it was buried in 80 meters of ice that built up in only 50 years. How do we know it was 50 years? Because we know when the plane crashed and they know when they went back for it. 80 meters of ice is 250 feet of ice. So how fast did that build up? That was very quick. So no one can say, well, that took millions of years, because they know when the plane crashed, where it crashed, and where they had to dig it out. Isn't that incredible? There was another rescue effort for the other planes, and they are now buried in 120 meters of ice only a few years later. So to go from 50 years and 80 meters up a couple years later, there's now 120, which is, I don't know what the math is about 370 feet of ice. So how long does it take to build up ice? Obviously not very long. That is very important because it doesn't take millions and billions of years for an ice age to happen. There are also references in the book of Job. We looked at the book of Job to look at dinosaurs this morning. Job also has a few things to say about ice. Out of the south comes a storm, out of the north the cold. From the breath of God, ice is made, and the expanse of the water is frozen. So Job is obviously going through a cold spell there. Have you entered in the storehouses of the snow, and from whose womb has come the ice, and the frost of the heaven who's given its birth? Water comes hard like stone, and the surface of the deep is imprisoned. So Job is obviously on this ice fix because he's saying, look at all the snow, look at all the ice. Now, what is the current evidence? Well, this is what I call these U-shaped valleys. They are these massive skateboard ramps for 14-year-olds, And what happens is that those are thousands of feet, but these are caused by the glacial receding of the ice, and it makes a U shape. If it's carved out by water, it makes a V shape, simply the way the erosion works. Now, in these U-shaped valleys, there are some massive boulders that are carried along the top, and then they're dumped in really weird places. This is called a glacial erratic, and this is one of the great glacial erratics in the world. In fact, it is the largest one in Okotoks. My father was an engineer in Okotoks, and so I know exactly where this place is. This thing is massive, and there is absolutely no rock anywhere in that part of southern Alberta that has anything like that. That thing was carried on the piggyback of a glacier, and then when the glacier either melted or couldn't hold it anymore, it plunked it down right there in good old Okotoks. Over the years, I decided, I wonder where the funkiest glacial erratic is in the world, and I think I found it. Yosemite National Park. The tree is there so that you know that this is not trick photography, and no, you cannot go running underneath it and push it over, because if you do push it and it happens to go the other way, they will find you as a fossil later, because you're never going to get out of that. It is indeed fenced off. I believe that God, in his great wisdom and sense of humor, he took this massive boulder and directed it and said, I'm going to place it down gently just right there, and I'll see if people figure this out. It is beautiful as it sits there on that very funny slope. If you'd like more about the Ice Age, I think the Answers book has it. These other two, the DVD is a great DVD by Michael Lord, who works for CMI, and he talks about that. And then this is a children's book, which is, well, what was life like in the Ice Age? Because obviously people lived at that time. Job obviously came after that. And what is going on, and what would life have been? It's a great story written for kids, and you can order that online if that is something of interest to you. I hope that gives you enough of an interest. I think that our time is up. Is that okay? If you want to talk afterwards, we can do that. Otherwise, I think you guys have been great. Like, you've been sitting on your butts for a long time, and so I appreciate that you've done that. It's been an honor for Elaine and I to serve you. There's a connection here because my daughter and my grandkids and the other little ones, they come here, and so it's just a blessing that you folks are following after God's word, that you have a pastor who has no compromise for these things. I hope that some of the things that I've shared today will be remembered, but mostly I hope that you've been encouraged in your faith, that you can trust in God's word. Amen? Amen. Very good.
All right.